TGIF, happy Friday. Let's get into container security and Docker security specifically. I'm just going to talk about a little overview of Kubernetes. What are the Docker security checks? So we're going to look at a couple high-level security checks. Then we're going to do detailed checks like we do on a GRC, governance, risk, and compliance check for a small company. What are containers? Containers are a lightweight, more agile way of handling virtualization. Rather than spinning up an entire virtual machine, a container packages together everything needed to run a small piece of the software. The container includes all the codes, its dependency, and even operating system itself. This enables application to run almost anywhere, desktop computer, traditional IT infrastructure, or cloud. The container uses a form of operating system, OS virtualization, but simply leverages the feature of the OS to isolate processes, control the processes, access to the CPU, memory, and disk space. So if we look at the current diagram, to the left is a current virtual machine container, to the right is actually a container. So really what's missing, you can see, is the guest OS. So that makes a container usually more lightweight, less resources and less space. Containers are really loved more by developers. I think admins are just actually really getting the hang of containers. Admins usually traditionally do the standard virtual machine. So the two top containers out there are Docker and Kubernetes. Docker is more of a image file disk. Kubernetes more orchestration and actually handling the process of actually moving your code from production development to operations. So a lot of people actually can run Dockers and Kubernetes together. I've never seen that really in production, but I've been reading a lot of stuff about people running Docker and Kubernetes together. So Docker is currently the most popular container platform. Docker appears on the market at the right time, was open source from the beginning, which likely lead to the current market domination. 30% of enterprises currently use Docker in their AWS environment. That number continues to grow. When most people talk about Docker, they're talking about the Docker engine, the runtime that allows you to build and run containers. But before you can run a Docker container, there must be built, starting with a Docker file. The Docker file defines everything you need to run an image, including the OS network specification, the file location. Now that you have the Docker file, you can build an image which is portable, static components that gets run in Docker engine. And if you don't want to start from scratch, Docker even has a service called Docker Hub where you can store and share images. Kubernetes handles a large volume of containers and users simultaneously. An application may have thousands of containers and users interact with each other at the same time. Managing and keeping track of these interactions require a comprehensive overall system design, especially for that purpose. Managing service discovery, communication between containers. How does a user find a container and stay in contact with it? Providing each microservice with its own built-in functions of services discovery would be repetitive, highly efficient at best, and in practice it would be likely to lead to intolerable slowdown or gridlock at scale. Balance the load efficiently in an ad hoc or unorchestrated environment. Loads at the container level are likely to be based largely on user requirements at the moment, resulting in a high imbalance of load at the server level, along with logjams results in efficient allocation of resource, resulting in a limited availability of containers and system resources. Load balancing replaces the semi-chaos with the order and efficient resource allocation. Multi-platform deployment, orchestration, manage the otherwise very complex task of coordinating operating systems, microservice availability, synchronization in a multi-platform, multi-cloud environment. So once again, you can run Docker and Kubernetes together, they seem to have different strengths and weaknesses. So we'll probably focus that on later, running those two together. Probably look at that in a separate video. So now we're going to slowly go through the Docker checks. These are the OWASP checks, and it's the top 10 for the Docker settings. Rule number 1, keep the host and Docker updated to prevent from known container escape vulnerability, which typically ends in escalation to root administrative privileges. Patch the Docker image and Docker machine is crucial. Right, also, if you look on the slide, there's an exploit called Dirty Cow that actually shows you how to execute a privilege escalation on a Docker machine if you didn't keep it updated. Rule number 1, do not expose the Docker daemon socket, even if it's to the container. The Docker socket, docker.socket, is a Unix socket that Docker is listening to. That is the primary entry point for a Docker API. The owner of this socket is root, giving someone access to the equivalent of giving unrestricted root access to your host. Do not enable the TCP/IP Docker domain socket. If you run in the Docker domain, use that -h TCP 000-0, right? Rule number 2, configure the container to use an unprivileged users is the best way to prevent privilege escalation to an attack. This can be accomplished in 3 different ways as the following. Let me get back to that. 2. You can build a runtime user option in Docker. During the build time, you can simply add a user to a Docker file, or you can enable the user namespace support. Username remap equals default. So you don't want to run Docker as root, because somebody, if it actually took over Docker, right, they would actually have root privileges if that Docker container ever got compromised. Rule number 3, limit capabilities. Grant only specific capabilities needed for the container. The Linux kernel capabilities are set privileges that can be used for privileged Docker by default. Runs only a subset of the capabilities. You can change it, drop capabilities, or you can add capabilities next to it. And remember, do not run the container with this privilege flag, right? Because that means it will be run without privileges such as admin on that container. So once again, you want to run least privilege on your Docker container. Rule number 4, add the no new privileges. Always run your Docker image with --set-op equals no new privileges in order to prevent escalation of privileges using the set UID or the set GID on your binaries. Right, so once you get your Docker set by your admin, you can lock it down. So when you put it in production, if somebody hacks it, they cannot do privilege escalation with the no new privilege flag. Rule number 5, disable intercommunications. -ICC equals fault. By default, inter-container communication is enabled. It means that all containers can talk to each other using Docker 0 network bridge. This can be disabled by running ICC flag equals false. So one of the big security violations, especially with the solar winds, is east and west traffic. So if you're running multiple containers next to each other, if one container gets hacked, if the bridge is open, they can jump to every other Docker container. But if you cut the intercommunication bridge off, they couldn't jump from container to container. They would actually physically have to figure out how to get to each container from the outside. They couldn't go on inside and jump to each container. Rule number 6, use the Linux security module, security comp, and AppArmor file. First of all, do not disable the default security profile, considering using security profile, security comp, and AppArmor. So what this does is on a Linux system, you can actually lock down the privileges a little more on your Linux distribution, what apps you can run, what processes you can run, what processes can talk to each other. So you would have, we call it a security onion with layers. You cut the intercommunication off, which was rule number 5. Then you lock down which apps can physically run actually on your Linux distribution. Rule number 7, limit resources, memory, CPU, file description, and processes, and restart. The best way to avoid a DOS attack or DDoS attack is by limiting resources. So if somebody's doing a denial of service attack, but you're only going to let that Docker only take so many CPUs, so many processes, and it'll just run at that and block everything else. You can actually make the processor take all the CPU. Then once again, you will affect every Docker app on that host machine. Security check number 8, set file systems volumes to read-only. When containing a read-only file system, use read-only flag, for example. If an application insider has to save something temporarily, you can actually open up the files. So if somebody got access to your file system for that particular Docker, they couldn't make any changes to the actual Docker components of itself while it was running, because it would be read-only. Rule number 8, these are some static tools you can use to actually scan vulnerabilities, scan the image of your Docker file. So in another video, I'm probably going to look at the free and the built-in tools, Declare and the Trivy, and the Inspect.io and DevSec.io, just so we can scan and see the vulnerabilities that would actually be in a Docker. So once again, since I'm doing GRC, governance, risk, and compliance, I will run these tools to see what vulnerabilities were available on that Docker and what the teams need to do to fix it, the development teams or the admin teams, right? So that would be my first scan to kind of figure out what's going on with the Docker settings for that container. Rule number 2, set logging level to at least info. You want your Docker to log all your events so you can keep track to figure out what people are doing, what people are doing, what devices are doing, and what processes are doing. So you want all that logged at a certain log level so you can actually go in and track it. And once again, too, is we're going to take these logs, we're going to push these off to a SIM. So if somebody actually hacked our Docker and took it over, this logs will be on a different computer, and we can go through and do post forensic analysis to figure out who hacked our Docker. Hopefully, if somebody actually stole some information from my Docker and SFTP to somewhere else, right? We need those logs to do that forensic investigation. Rule number 11, lint the Dockerfile at build time. Many issues can be prevented by following the best practice when writing a Dockerfile. Adding the security linter as a step in the build pipeline can go a long way in avoiding further headaches. Some issues that are worth checking are ensure a user's directive is specified, ensure a base image version is pinned, make sure an OS package versions are pinned, avoid the use of add in favor of a copy, avoid the use of APT and upgrade packages, avoid the curl bashing in a run directive. So these are various ways people would use to actually hack your Docker image. So now the next level of checks we would do is the STIGs. That's actually a DoD checklist. If you're trying to run for a government agency or a higher level security or for the Department of Defense, these are actually the security checks you need to actually run on your Docker instance. We're actually going to go through these quite quick. These are the high vulnerabilities. Once again, for a government installation check for Docker, there are currently 28 of these. So we're going to go through these. The V is the vulnerability code. So if you want to actually go on Google and Google these, you can actually look at the STIG. And on there, they give you additional information, how to actually check this how to actually check the setting, the discussions of why they actually are setting this particular setting for the Docker. So let's kind of walk through them. FIPS mode must be enabled on all Docker images in the enterprise node. What FIPS is, it's basically you sending your encryption off to a government installation for them to check on it to make sure it's valid. The Docker enterprise host network space must not be shared. All Docker containers root files must be mounted as read-only. Docker enterprise host device must not be directly exposed to containers. The Docker enterprise default SEComp profile must not be disabled. Some of those, of course, we went through earlier, but these are actually more detailed and more in-breadth checks of those. All Docker Enterprise containers must be restricted from acquiring additional privileges. The Docker Enterprise host use namespace must not be shared. The Docker Enterprise socket must not be mounted inside the container. The Docker privilege ports must not be mapped within the container. And the Enterprise Docker file ownership should be set to root:root. So once again, I just went over the top 10 of these particular STIG check. In the next files, you can see the additional checks. So I'm gonna let you go through these at your leisure. If you're actually going through Docker, you can actually go through these files, these checks to make sure your Docker are secure. So that was the last file. So once again, we went over the Docker security checks for your Docker image. Talked about container security at the high level. We specifically talked about Docker security. We went over the top 11 general security checks. We talked about Kubernetes overview of how it handles orchestration. And theoretically, you can actually run Kubernetes and Docker together. And also, we went over the STIG comprehensive checks. I went over the top STIG vulnerabilities. And if you want to go through, I had 3 other slides with additional, I think it was 30 STIG 1, category 1 checks that you need to actually get fixed or get compliant if you actually want to run your Docker actually in a government installation. Once again, cybersecurity for the people. This is ProfessorBlackOps. Please subscribe. One of my subscribers actually requested a container security review. So if you need me to go over something specifically, just put it in the comments box, or there's actually an email on my page. You can actually send me a request of things you actually want me to review. Once again, ProfessorBlackOps, have a great Friday.